A sequence of tokens can be understood as a set of elements that, when combined together, they fulfill with a semantic meaning. In the context of natural language, we can represent every single sentence as a sequence of words. So for instance, in this sentence, I love to watch cat videos and listen to music, we can also visualize this information as a sequence of words. We will be I love cat videos and so far and so on. In the particular case of source code, we can also represent that information as a sequence of elements that have been used to define the source code. In this example, we are defining the hello world function, and we can also represent this information as a sequence of elements. Sometimes, given a sequence of elements, we may want to predict what is going to be the next token. And for doing that, we can rely on artificial intelligence techniques such as large language models. A large language model can also be visualized as a probability distribution where, given a context window or the previously defined sequence of tokens, we want to predict what is going to be the next word, what is going to be the next token with the highest probability. In this example, imagine that we have this sequence of tokens in the source code, public static void main, and then we want to predict what is going to be the next token. If we use a large language model to accomplish this task, at the end we will have a probability distribution with every possible word in the vocabulary with an associated probability. The model will choose the highest probability. In this particular example, it will correspond to the token args. Since source code can define different types of elements according to the rules that are present in the programming language, that token may be an operator, an identifier, a statement, an integer, or any kind of element that is defined in the programming language. Now, let's consider this example. We want to rely on a large language model to generate the full body of this function. This function is intended to receive a number and then determine if the given number is a prime or not. It will return true or false depending on the case. The large language model, in this case Copilot, is going to use the previous context information of the tokens that have been used to define the function until this point to determine what are going to be the next tokens. If we rely on the model, at the end we will have a prediction of what are going to be the most probable tokens in that probability distribution, but that prediction may be sometimes correct or not correct. We can represent the source code using abstract syntax trees, where every single node corresponds to a portion of the source code. In our previous example, we just generate the body of a function that receives a number and then determines if that number is a prime number or not. In this kind of visualization, every single token that was generated by the model is associated with a leaf node. We can also aggregate those leaf nodes to consolidate subtrees in that AS3 representation. The nodes that are represented in blue colors are the ones who obtain the highest probability values, while the red nodes are the ones with the lowest probability values. We can use this visualization to answer more specific questions about the representation of the source code and how certain structures were generated.